For problem 3, the last problem on the first page of your outline, keeping in mind that you should be pretty much writing down everything I write down in these videos. Although I'm not giving you necessarily the quadratic formula, this is something that you should definitely have written down because I'm writing it down. So whether you Google it or need a refresher on it, the quadratic formula is pretty much the worst case scenario if we're asked to solve a quadratic formula or solve any type of equation where there are 3 terms or 2 terms. So this helps us solve a quadratic, and it's kind of the worst case scenario. So if all else fails, you can use this, meaning you can't factor it, you can't factor by grouping, you can't use completing the square if you know how to do that. So if all else fails, you can use this. And if you need that refresher, this is going to be negative b plus or minus square root of b squared minus 4 times a times c all over 2a. If I taught you for algebra 2, you can think of this like the ice cream man when he's coming down the street. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And a lot of this is just based off of when all of the terms are on the same side. So that's a good goal to keep in mind. So our goal for this is to put all 3 terms on the same side. Because we could just recite this formula all day, but it's only if you know how to use this, that's the most important part. And that should be the main objective, is to have all 3 terms on the same side. So if we take a look at this, what looks as if it's going to be something we need to move? So although 2x squared is one term, I personally like to keep the a term positive, so I'm actually going to keep 2x squared there. But 6x and negative 1, I would definitely want to move. So if we think opposites, deducting 6 and adding 1 to both sides, we're left with 2x squared minus 6x plus 1. And this now all equals 0. If we take this further, we can then denote what a is, and I'll color coordinate this accordingly. So let's say that a is blue. Let's have red be B. And then we'll keep C as that constant of 1. So hopefully color coordinating works here. So when we're taking negative b, we're taking the opposite of b. So if b is negative 6, in here we want to subtract negative 6. Please be consistent with this equation. We then have b squared, so negative 6 squared. We're deducting 4 times a, which is 2, with 1. This is all over 2a. If we start to simplify this as much as possible, we're taking the opposite of negative 6, so this should be just positive 6, plus or minus the square root of 6 squared, so 36, deducting 4 times 2 times 1, so subtracting 8. This is all over 4. So we can continue this fashion, trying to simplify this even further. In the radical 36 minus 8, we should be able to say that that's going to be the square root of 28. And this is all over 4. This is still going to give us our x values we need. This we can simplify further because this can be treated like 2 different fractions. So we could rewrite this as 6 over 4 plus or minus the square root of 28 over 4. If you really want to take this further, 6/4, you could rewrite to 3/2. keeping in mind your plus or minus square root 28 over 4. And so this actually gives us two different answers. If we look at this closely, we know that we're going to be taking an additional root 28 over 4, or deducting it, which gives us two answers. So we could say that x equals 3 halves plus 28 over 4, or 3 halves minus 28 over 4. And for these types of problems, I'm just fine with you leaving the fraction. I may ask you to expand the fraction as much as possible, which would get you to here, in which case separating it into two fractions, that's really crucial. If we decided to check our calculator for what the outcome is going to be, the 3 halves plus the root 28 over 4 would be approximately 2.82. And if we took the other setup, that would be approximately 0.177. So if you're curious about the decimals, that's what this would get us.